In this video, we are going to see how we can perform Internet of Things open source intelligence. Open source intelligence, OSINT, is the process of collecting data about targets without communicating directly with the systems. It's one of the initial steps for any assessment. You should always perform it to get the lay of the land. For example, you might download and examine device manuals and chipset datasheets, browse online forums and social media, or interview users and technical personnel for information. One of the easiest ways to gather sensitive data about a target is through search engines, which should be your first step in gathering information. Google Dorking may help you identify important documents about an IoT device. For example, you can try to find device manuals which can provide a ton of information about the inner workings of devices. You can usually find them on the device vendor's official website. If that fails, try advanced Google searches for PDF documents containing the device name. For example, you can try the Google Dorks as shown. These dorks will help you find PDF documents related to a device. We can try to find PDF files related to a common Wi-Fi router, and we can see download user manuals, specification documents, etc. It's surprising how much important information you can find in manuals. They can even reveal default usernames and passwords that often remain in production environments, detailed specifications of the system and its components, network and architecture diagrams, and troubleshooting sections that help identify weak spots. Similarly, you can use advanced dorking techniques to find sensitive information and login pages of industrial instrument control systems. We can look for the text containing the datasheet related to the device as shown. We can then download the datasheet and get the relevant information. We can also search for login pages. Here, we can see login pages of industrial instrument control systems. Now, let us see what information we can get from FCC ID of a device. The Federal Communication Commission, FCC, is a general body to regulate various devices emitting radio communications, which is most IoT devices. The reason for the regulation is that the radio spectrum is limited, and devices are operating at different frequencies. In case of no regulatory body, one can decide to manufacture and choose his or her device to use a frequency that might already be in use by another device and lead to interference in the communications of other equipment. Thus, any device that uses radio communication must go through a set of approval processes, which involves several tests, after which approval is granted by FCC for the device. The FCC ID of a device will be the same for a given model of a specific manufacturer. You can find the FCC ID of the device either printed on the device itself or by looking online at different sources. By searching for a specific device's FCC ID, you can find details on the wireless operating frequency, internal photos of the device, user manuals, and more. You may also find relevant datasheets which might lay out the chipset pins used for debugging. You can use the websites as shown. For example, let us look for information on a webcam. You can find its FCC ID on the bottom side of the device. Now go over to fccid.io and search for the FCC ID. You get the complete details of the camera. You can see the supported frequency ranges, user manuals, etc. One of the most interesting things to look at while analyzing the FCC ID information is the internal pictures of the device. The pictures also reveal that this IP camera has a UART interface as suggested by the 4 pads shown in the photo. This is also something we can use to extract firmware from the device. Patent documents can also reveal sensitive and important information about a device. Patents can provide information about the inner workings of certain devices. Try searching for a vendor name at patents.google.com and see what comes up. For example, the keywords Medtronic Bluetooth should pull up patents for a communication protocol between implantable medical devices, IMDs. The patents will almost always contain flow diagrams that could help you when assessing the communication channel between the device and other systems. Now let us look at some IoT search engines. Shodan is often referred to as the search engine for hackers because it allows users to search for internet-connected devices and systems based on various criteria such as IP address, ports, banners, and more. It is commonly used for security research, and it can be used to find vulnerable devices, industrial control systems, webcams, and other internet-connected resources. Censys is another search engine that focuses on internet-wide scanning and indexing. It provides a searchable database of information about hosts and networks on the internet. Censys is often used for security research, asset discovery, and monitoring internet-wide trends. We will be looking at Shodan and see how to do reconnaissance on IoT devices. Shodan supports a number of query types to shortlist IoT devices on the internet based on different criteria. You can search with port number, device name, protocol name, or other headers. Once you open Shodan, you can find a cheat sheet on the home page. You can use this cheat sheet to search IoT devices. You can click on Explore and browse some popular IoT devices. For example, let us browse some web cameras. Let us open the first result. Surprisingly, this device has already been hacked. We can see some credentials. We can also see the complete user account hashes. Now, let us browse some open Android IP cameras, and we have a bunch of results. Let us see if we can view it live. And we can see the camera feed live. Similarly, we can also search for other IoT devices. Let us search for MQTT devices. We have more than 500,000 results. You can also view more details about the results by clicking on the More button. Here, you can further filter devices. For example, we can directly search for vulnerable devices. Here we can see a summary of devices vulnerable to a particular CVE. We can also filter devices by country with a country filter. Further, we can shortlist devices with connection code 0, which is an indication that no authentication is required to access the device. Similarly, we can search for Modbus-based devices by searching for port 502. We can search for SCADA devices in a specific country. And even if we want, we can directly search for the vendor name and shortlist devices. Different headers can also be used for searching devices. For example, we can directly search for devices with UPnP functionality that also have an exposed web server as shown. Now let us see Censys search engine. Here, also you can search with protocol names or port numbers. So, in this manner, we can use open source resources to perform OSINT for the Internet of Things.